10.4, we're going to look at random variables and something called expected value. And we're going to start off with an example that should be review. We have the probability of winning equal to 0.35. Question is, what is the probability that you win on the first or second turn? And to find this probability, we can use our addition rule. Probability of the first win plus the probability of the second. But then we have to subtract the probability of winning on the first and second. Well, the probability of winning on the first roll, or just winning, whatever this is 0.35. If we play again, the probability of winning is still 0.35. And then we have to subtract off 0.35 times 0.35. This is equal to 0.5775. So roughly 58% of the time we'll win on the first or the second turn. That's one way to approach this problem. Another way is using a tree diagram. We'll either win or lose, and the probability of winning is 0.35. Probability of losing would be 0.65. And if we win, we've satisfied the criteria that we have here and we would stop playing. If we lose, we would play again. And so what we have are two paths that lead to success for us. The first path has a probability of 0.35 plus the second path, which we would need to find by doing 0.65 times 0.35. And this again is equal to 0.5775. The expected value is what we expect to happen in the long run. It's the mean result of many, many trials. And what we talk about is the expected value for a random variable, which is a numeric representation of the outcomes of an experiment. Some examples of the two types of random variables there are, discrete and continuous. I'll write down a few here. A discrete random variable is one that's countable. And what I mean by countable is, an example would be how many cars go through a stop sign in a day. We could stand and count that. Or number of students to walk past the principal's office in one class period. That is a countable random variable. A continuous random variable is one that's measurable. An example of this might be the heights of students in pre-calculus, or the length of someone's arm in the sophomore class. Things that you measure. It can have fractional values. It has a continuous measurement system for gathering that data. To find the expected value for a random variable, what we do is we take each value the random variable can be and multiply by the corresponding probability. And we're going to add all of those things up. In this problem, we are looking at rolling two dice and finding their sum. So the random variable x can have the values 2, 3, 4, up to 12. And then we look at the probability of all these things. Now, with these sums for 2 dice, if you don't have this idea of the 6x6 grid in your mind, these problems can be a little bit of a pain. So we can fill in sums here. And so on. We could fill in the rest of this table until we hit 12 down here. So the probability of each of these, we can look easily at the table. Probability of getting a 2 is 1 out of 36. Probability of rolling a 3, there are 2 of those in that chart. 2 out of 36, we could also write that as 1 over 18. There were 3 4s, 3 out of 36 is 1/12. There were 4 5s in that table. 4 out of 36 is 1/9. There were 5 out of 36 6s. And finally 6 out of 36 7s. So the probability of 7 would be 1/6. And then from there the probabilities get smaller again. Probability of getting an 8, there are 5 of them. There are 4 9s, so that probability is 1/9. There are 3 10s. There are 2 11s. And there is only 1 12. To find the expected value of rolling a die, or 2 die, over a long period of time, what we do is we take each value, the first one being 2, times its corresponding probability. And we add all of these things up. And when we do this calculation, we end up with 7. If you didn't get that by doing this calculation, you made a mistake plugging your numbers in. And what this means is that if we roll 2 die for a very long time, we would expect an average of 7 to come up on our sums. And this idea of expected value is very applicable to something along this lines, where I'm going to reach into this wallet and I get 1 bill from it. What is the expected value for this? We're going to make a table again with our random variable x and the probability for each x. The values the random variable can take here, random variable stands for what we're getting from Grandpa. We could get $1. We could get a $5 bill. We could get a $10 bill. Or we could get a $20 bill. In that wallet there are 8 bills. 2 of them are 1s. So 2/8. There are 3 $5 bills. So the probability of getting one of those is 3/8. 2 10s. And 1 20. Our expected value is equal to 1 times 2/8 plus 5 times 3/8 plus 10 times 2/8 plus 20 times 1/8. And what you should end up with is 7.125. What this means is that if I go visit Grandpa a whole bunch of times and repeat this process with the same bill combinations, I would expect on average to be making just over $7 every time I go visit. That's what expected value is telling me.